Okay, so one more example of a commutative group, just to make sure that you're remembering and able to identify all of the steps. So the elements of this, we've got 4 Greek letters. We've got an alpha, we've got a beta, we've got a gamma, which looks like a weird Y, and then we've got a delta, which is a D with a squiggly top. And then the binary operation here is the music symbol. So that's the best that I can do. And so now we are going to go ahead and determine whether this is a commutative group, going through the 4 steps. And if no one minds, I think I'm just going to use this space up here to begin with. That way I don't have to slide the table out of our screen. So the first thing I got to do is determine, is this closed? And so I'm just going to go through. Do I have alpha, beta, gamma, delta? So I've got alpha, beta, gamma, delta. I've got alpha, beta, gamma, delta, alpha, beta, gamma, delta, and then alpha, beta, gamma, delta. So yes, it's closed. All the results are all alpha, beta, gamma, and delta. Great. The second thing is there an identity element? Remember, when you're going through your homework, if any of these fail, you're done. You've got to go no further. You can then immediately answer, no, it is not a group or a commutative group. So the second thing, do I have the same column, alpha, beta, gamma, delta? Well, it's not this first one. Alpha, beta, gamma, there it is. So the identity is beta. Great. The third thing is I'm going to identify whether or not everything has an inverse. So the inverse is the element that produces the identity, which is beta. So coming over here, I'm going to take alpha and I want to know, what do I music sign it with to get beta? And I'm going to do it with gamma. Okay, so that is this right here that produces beta. Then we're going to do beta, and I've got my music sign, and beta combined with itself. So beta is its own inverse. And then gamma with my music sign. Okay, gamma with alpha produces beta. And then last but not least, delta, and delta combined with itself. Delta gives me beta. So everything has an inverse. So every element, all elements have an inverse, which is what we're looking for. Next thing I'm going to do is I'm going to verify the associative property. Somebody asked me on the way out of class, how do I know what elements to pick? And the answer is you pick whatever 3 you want. You could pick 3 of the same. You could pick 2 of the same and something else. It absolutely doesn't not matter. So I'm just going to do alpha. I'm going to music sign it with parentheses. We'll go alpha again, and we'll music sign it with delta. And so then the only thing you're going to do now is you're going to use these same 3 elements. You're just going to move the parentheses. So alpha combined with alpha, and then combined with delta. So using the table over here, alpha combined with delta. So alpha starting here combined with delta gives me gamma. And then alpha combined with gamma gives me beta. So I get beta when I do things that way. And then alpha combined with itself, alpha combined with alpha is delta. And delta combined with delta gives me beta. So the associative property, we have found an example that works. Okay, so that was step 4. And then step 5. Step 5 is to determine, is this commutative? So here's my diagonal, and I have across the diagonal here, I have alphas. Across the diagonal here, I have betas. Here and here, I have gammas. I have alphas and deltas. So this is indeed commutative. All elements above and below the diagonal are equal. The same. So answering the question, is this finite system a commutative group? The answer is yes, it's a commutative group. I'm going to abbreviate commutative. Perfect. There it is, last example.